This is problem 8-90 from section 8.2.2. Consider this geometric sequence. I to the 0, I to the first, I squared, I to the third, I to the fourth, I to the fifth, all the way to the I to the 15th. You know that I to the 0th power is worth 1. Anything to the 0th power is worth 1. You know I is just I squared is negative 1. Calculate the result for each term up to I to the 15th and then describe the pattern. So I'm going to do this kind of in a certain way. I'm going to say I to the 0, which we know is 1. I to the first is just I to the second is negative 1. I to the third is really the 1I to the first times I to the second. So that's really I times negative 1, which is negative I to the fourth is I squared times I squared, which is negative 1 times negative 1, which is positive 1. Okay? So we're going to continue this down. So I have I to the fifth is going to be, it could be I to the fourth times I, which is just an I, right? I to the sixth is I to the fifth times I to the first, so that's I squared, so that's really worth negative 1. I to the seventh would be I to the sixth times I, which is negative 1 times I, so that's negative I. And I to the eighth is really like I to the seventh times I to the first, so negative I times I, negative I squared, which would be positive 1. Do you see a pattern here? It's going I, negative 1, negative I. Well, let's start with 1 here, I guess. 1, I, negative 1, negative I. Then it'll be 1. The next one would be I. The next would be negative 1. The next would be negative I. Okay, we get a pattern going. It's repeating the same 4 numbers. This is an I right there in a row. Okay? It was 1, I, negative 1, negative I. So if we continue with our numbers, we write down here. That's going to be 1. This is I. Then it's the negative version of them. Negative 1, negative I. Okay? So that's the pattern. It's repeating the same 4 digits over and over again. 1, I, negative 1, negative I. Okay, that's for part A. Use your pattern to calculate those things. Okay? So I have the 16th is several of them here. So we're going to figure out, yes, there's a pattern, but it's kind of a difficult pattern to figure out for all these big numbers. I don't want to keep going and going and going. Oops, that is a 39, and I to the 100th was also in there. So notice that this pattern is repeating every 4 times, right? I to the 0 and I to the 4th are exactly the same. I to the first, I to the 5th are the same. It's 4 spaces kind of in between them. So if I have a multiple of 4 as my exponent, that's really going to be like I to the 4th, basically, right? Times itself that many times the pattern repeats. So I to the 16th is really like I to the 4th times I to the 4th times I to the 4th times I to the 4th, which is simply regular I to the 4th is worth 1. 1 times 1 all the time is just 1. Okay, so if it's a multiple of 4, it's basically just I to the 4th. Okay? 39, I could say I to the 36th times I to the 3rd. Right? You add exponents. Okay? 36 is a multiple of 4. Okay? So it's basically 9 of these multiplied together. So that's basically a 1. And I to the 3rd, we knew up here, was worth negative I. Okay? So I have this times negative I, so that gives me negative I is my answer. Okay? 100 is a multiple of 4. It's basically 25 I to the 4ths written down and multiplied by each other. So that's going to equal 1. Okay? So I have 1, negative I, and positive 1 again. Alright, for part C, let's see what that says. Okay? what is I to the 4n, where n is a positive whole number? That just is basically saying what we just said for I to the 16th and I to the 32nd and I to the 100th. It basically means I have n number of I to the 4ths being multiplied. And that's all that means. If I have I to the 20th, it's I to the 4th, times 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 I to the 4th, which is basically 5 of them, right? So to get this, I'd say 4 times 5 as my exponent. Okay. So if it's a multiple of 4, it's just basically worth 1, and it's whatever the extra part is what you care about. So let's look at D. There's some larger numbers, I think. Oh wait, no. So that's basically saying in general, I just said this out loud. This part right here is I to the 4th, basically, and then it's whatever it's extra. So this is really I to the 1st. This would be I to the 4th times I to the 2nd. This would be I to the 4th times I to the 3rd. If it's a multiple of 4, we just care about what is the extra part, okay? So now let's look at E. There's some bigger numbers, and let's calculate those based on if they're multiples of 4. So we have I to the 392nd, or 96th power. I can divide that by 4, and I would get 99 of them. Oops, I don't know what I'm doing. I to the 99 times 4 power. Okay, so I really have 99, I can't even read this stuff. I have 99 I to the 4ths being multiplied together. Okay, so I really don't care about this. It's basically just worth 1. It's a multiple of 4, it's just worth 1. Next one is I to the 397th. Well, this one is a multiple of 4, but there's an extra. Okay, it would be I to the 396th times I to the 1st. So this part we know is worth 1 from the previous question, so this is just I. Right? Now if you notice the rest of these problems, I to the 398th, that's just 1 more. So it's going to really be worth I squared because there's 2 extra compared to the original problem. Okay? So if it's a multiple of 4, it's going to be worth 1, and then I figure out how much extra there would be. So I to the 399. Okay, so if I have 99 I to the 4ths, it gets me to 396. I have 3 extra. Oops, I never did this one. That's -1. And we know the pattern here is going to be repeating itself. 1, I, -1, -I. Okay, that's the pattern. So hopefully this makes sense, especially the next problem, 91 of the homework. I would divide the numbers by 4, see if it's a perfect multiple of 4. If it is, the answer is worth 1. If it's not, how many extra do you need to get there? Okay? And then that's basically, it's I to the whatever extra exponent.